I'm on chapter 11, page 613, structured data or structs in C++. So the book starts by defining what are abstract data types. So abstract data types are any data type that the creator is the programmer. So any data type that the programmer creates, it's called abstract data type. They have their own data and their own sets of operations that may be performed on them. So it's a data type that's going to have its own data and its own functions or methods or operations that perform certain tasks on those data. So imagine it's an object, and inside that object you have variables, whether it's integer or chars or doubles, and then you have also functions that provide some functionality on those data. So an abstraction is a general model of something. So basically you create the blueprint, you say, okay, I want this struct. This struct has an integer, has a double, and then you can create instances of that blueprint. Just like building a building, an engineer draws the blueprint, then you can create as many houses as you want out of that same blueprint. For example, the term dog is very abstract. It defines general type of an animal, not specific breed of dogs. It captures the essence of what all dogs, without specifying detailed characteristics of any particular type of a dog. Then they go by defining data types in general. We know what are data types. Then they start by structures. So C++ allows you to group several variables together into a single item known as structure. The format goes like this. So I'm going to have struct, and then here what's called tag, or basically the name of the struct. For example, I'm going to call it my struct, my first struct. Then you open curly braces, you close curly braces. Don't forget the semicolon, but Visual Studio puts it for you. Then here you have the variable declarations. You can have as many as you want as long as you are within this scope. The example that the book shows is a payroll. So a payroll, let's call it payroll. From the book, it has an int employee number, like an ID. It has a string name. Let's include a string. It has double hours, double pay rate. No, go back. And it has gross pay. So this is my blueprint. This is the abstraction that I created, general type of a payroll. This object or this data type has variables in it. So now I can go and create instances of that class. For example, the same way I create an integer, my integer, what I basically do is I specify the data type and then I give a name for my variable. So this is one instance of the integer data type. So similar fashion, I have the data type, which is a payroll, and then I need to give it a name for my variable. For example, my first instance. So this is my first instance of that struct. This variable by itself, included in it, I have integer, string, double, double, double. The way to access those is by using the dot. So if I say, hey, my first instance dot, now it opened the capsule and it shows me what's in it. By default, everything inside a struct is public. Later, when we learn about classes, I think we went over it in brief. You're gonna have 2 sections and 3 sections later. You're gonna learn you have a private, protected, and public. Private means no one can access it from the outside. Public means everything can access, anything can access it from the outside. By protected, we'll keep it for later. By default, with classes, everything is private. However, with structs, everything is public. So even if I didn't specify that this employee number is public, by default, it is public. So if I hit dot, I see it, employee number. I can give it, for example, number. Then I can go to the later, so name, for example. I'm gonna say my name, hours, let's say 40, pay rate, let's say 10, gross pay, let's say 100. So here I populated my instance. I accessed my instance, and these are grouped together under my instance, and I gave them some values. The same way I accessed them to give them value, I can access them to display my values. So just like I'm displaying an integer, I'm specifying my integer, my instance, and then I'm accessing it because this instance has a group or set of data under it. So I'm accessing it with the dot and displaying. Now when I run, I'm gonna display 1. So here it is 1 because I only displayed one thing. If I stop here and I rerun again, I can hover my mouse on my instance, I can expand, and then I can see the values. Here they are, a group together under one variable. So that's the idea of structs. Let's see what the book also does. In topic 11.3, it tells you that the way to access structure members is using the dot operator, which allows you to access structure members in a program. There is a good example that they showed in 6.19. They basically created the struct, and then they started asking the user for values. So if I want to do something similar, I can say, okay, let's get the employee number, right? See out, enter the employee's number. Then I can cn into my first instance dot employee number. Just like how I read an integer, similar fashion. I tell my instance to open its capsule and show me what's in it. Then I pick employee number. So cn is gonna read from the display into employee number. Then I can tell it to enter the name. Then I can get line. And we all know why. Let me ignore first. Ignore one character because there's a remaining remaining new line from this procedure. When the user enters the employee number, he's gonna hit enter. So I'm gonna ignore that enter character, and then I'm gonna say get the entire line from cn to my first instance dot name. Then I can tell it to give me the how many hours. See out, how many hours did the employee work? Then I can cn into employee hours, hours. I can also ask what is the employees gross pay or pay rate, sorry, first. I can see into my first instance dot pay rate. Finally, I can calculate. So my first instance dot the gross pay in this case would be whatever my first instance has as hours. My first instance dot hours, it is multiplied, that would be multiplied by the pay rate. So my first instance dot pay rate. Pay rate multiplied by hours, I get the gross pay. Then I can see out everything. So see out, here is all the employees info. I can see out my first instance dot name. So I can say name ID, gross pay, pay rate. So here is number. Here is hours. Here is the pay rate, and here is the gross pay. Now let me step through with the F10. So I have my design here, and then I implemented it in an instance. Let me remove all these. So employee number right now is garbage. Even everything in it is still garbage. When I first created it, I didn't give it any value. I just said create an instance for me. So the data under that instance is still garbage, not set. The data is not set. Right now I'm setting it. So employee number, I'm gonna say 1. Employee name, I'm gonna say my name. Then I'm gonna say hours 40. Pay rate, I'm gonna say 15. Then gross pay has been computed. So my instance, I read hours, I read pay rate, so gross pay has been computed and set. So now I'm just gonna display. So here is all the employee info: name, number, hours, pay rate, and gross pay from one instance grouped together. So I'm moving to the next topic, which is comparing struct variable. The book needs you to know that if you have two structs, so my two instances, sorry. So my first instance, my second instance, this has its own copy of the data eventually. This has its own copy of the data. Right now, since I populated my first instance, if I go ahead and hover my mouse over and hover my mouse over my first instance, I'm gonna see values. However, if I hover my mouse over my second instance, it's still not set. These are two different copies of the data. Every instance has its own copy of the data. Although they are the same type, however, I can do something like this if my second instance greater than my first instance. This is not allowed. Let's say my first instance number is 1. Let's say my second instance dot employee number is 2. So it is greater than the employee number in the first instance. Still, I can't do this kind of comparison. It's not allowed. If you want to compare two instances, you need to compare them member-wise. Member-wise means you need to compare specific member to its relevant member. For example, here, if I meant to compare, by doing this, I meant or expected it to compare the employee number, then I have to specify employee number and employee number. Now this is allowed. This is how I compare two structs. I can't compare them just by their tags. I need to compare them by their members. So now if in case employee number is greater than my first instance employee number, then it will execute, else it will execute the else body. In this case, because employee number is 2, it will actually execute. Second is greater than. So go. My second instance now is 2, and this has been 1, so it is greater. Then the book goes for initializing, how to initialize. So here I populated my data. I created my instance and then I populated the data. However, there is a way to create a variable, declare it, and then assign it values on spot, similar to a constructor in classes. And the way to do this is, let's do it on second instance. Let me take these off. Actually, we no longer need these. Actually, let's keep this display. So I'm not gonna read them from the user. I'm just gonna compute and display. And then I'm gonna initialize all my instances. And the way to do this is open curly braces, close curly braces. Then the way they are declared from top to bottom, integer first, then the name, then hours, then pay rate, then gross pay. Gross pay we don't need to give it because we are computing it here. So in order, 1, comma, literal for a string, comma, hours, I'm gonna say 15. I'm gonna say hours is 40, let's say it's a week. The fact that I skipped the last one, then the last one is not gonna be set and will stay as is. So right now, 1 will go to the employee number from top to bottom, then literal for the string, then 40 for hours, then 15 for pay rate. If I start, gonna see when it displays the data, it is in order. So the string went to the name, the 1 went to the employee number, 40, 15, and the gross pay is 16. So I declared an instance and then I initialized it in place. The way to initialize a struct is by giving it values within curly braces in the same order that the variables are defined inside that struct. Then the book goes to show how to do an array of structs. Excuse me. So I can, the same way I can do integer array saying it's 10. This is basically 10 items of this data type, and I can access them by subscripting the name. I can say my array at position 0, my array at position 1, my array at position 2. The same fashion, I did this. I can go here and I say I need from this data type 10 items. Let me remove all the unneeded stuff. So I'm specifying it by telling it I need 10 items. I can iterate 10 times and ask the user to enter data. Let's do 5 instead of 10. Now on each instance, I'm gonna see out, enter name or number for I plus 1. Then I can cin into whatever my struct array at this position. This will return one item from that array. So my array has 5 payroll items. If this returned only one item, then this is returning a group of data. So I need to specify where am I reading to. I'm reading to this item and then dot employee number. So I'm reading into the employee number of the item at I from my array. I can do this same thing for the name. I can do the same thing for hours. Do the same rate for pay rate. Then I can say, hey, my struct array, I need the item at this position dot gross pay, and I need it to be equal to whatever this item's hours multiplied by whatever this item's pay rate. So here I'm iterating and asking for info. The same way I iterated, I can iterate and then display info. I plus plus. So here is the employee info at I. Here, now I can substitute my first instance with array at this index, array at this index, array at this index, array at this index. Now, if I start, my struct array, right now it has junk values. So it has 5 items and all the items have junk values. I started iterating. I'm reading number 1. Let's just hit continue and then stop here. So enter name for first item. Let's say my name. Enter hours. Let's say 10, 100. Then number 2. So enter number for number 2. I'm gonna say 2. Let's say this. Let's say 20. Let's say 200. Then 3. ID is 3. Name is whatever. Hours is 30. 300. For 4. I'm gonna say it's 4. Name for 4 is Jack. How hours 40 for specifying it, for differentiating it. The number for 5. Name for 5. Let's say John. 50. 500. Now that I populated info for all 5, I can hover my mouse over my array, and you're gonna see that it has all the info now in it. Here are the info 10, 20, 30, 40, 50, 1, 2, 3, 4, 5. So this will go over them one by one and display the info. So here is the info. Add 0, add 1, add 2, add 3, add 4, and done. So this is how to have arrays of your struct. The same way we can initialize one struct, one instance of struct, we can also initialize on spot on the same line an array of structs. So here, anytime I need to initialize an array, I need to open curly braces. That's just for the array itself. Then, in my case, every item in this array is a payroll. So every item needs curly braces as well. So 1, 2, 3, 4, 5. This has to take values in the same order the variables are declared. So I need an int, I need a name, I need pay rate, I need hours, then pay rate, and the gross pay can be computed later. Then I can have the same. $30 and have 4 Jack, 40, 400. Then finally John, 50, 500. I'm gonna run it, but I'm gonna stop only here to show you the values inside my struct. So I created an array of structs and I initialized them on spot. So if I hover my mouse now, expand, I'm gonna see the values. However, gross pay is still not initialized because I didn't give it any value. So this is how you initialize arrays of struct. Back to the book. Arrays of structures 11.5. Initializing a structure array, done, page 6 to 7. Then we go to topic 11.6, which is nested structs. Basically, they are telling you that you can have a struct inside a struct. So let's say I have struct called costs. Costs means it has a wholesale price, it has retail price. Any cost is for wholesale or retail. Then I have another struct that is called item. Some product, right? Any item in general, abstract. Every item has a part number, let's be consistent. So any item will have a part number, will have a description, and will have costs. Notice if I move this below the first, it's not gonna like it. Why it's not gonna like it? Just like any other similar situation. This is using costs, but from top to bottom, it doesn't know what is cost yet. So I'm telling my struct to use this data type, but it's saying I don't know what this type is. So I move this before it. Now the compiler compiles from top to bottom, learns about costs, and then goes to item to define it, sets costs, and knows about it. So in this case, we're gonna, since it's nested, then we're gonna have to access an item, then access costs, then access members of those costs. For example, let's say I have date and place for employee info. So I'm gonna have a date. Every date has int month, int day, int year. Then I'm gonna have a struct, another struct called place. Now every place has street, has city, has state, and finally has a zip code. One abstract, another abstract. Then I have another struct called employee info. Now, any employee has a name, has a number, has a birth date, so it's date, this data type called birth date, and has a place where it lives, where that employee lives, so residence. These are nested structs. It's a struct that has a structs in it. Oh, this is old. So now for my main, I can say, hey, I need an instance of this. I'm gonna call it manager. Now every manager has a name. So manager dot name is, for example, my name. Every manager has a number. So I'm gonna say, for example, 1. Then I'm gonna get the manager birth date. So I'm gonna say manager dot birth date dot day. For example, I'm gonna say it's 10. Then the manager dot birth date dot month. I'm gonna say October. Then manager again dot birth date dot year. I'm gonna say, for example, 1990. This is for the date. Notice the 2 dots for the nesting, because birth date is struct inside manager. So accessing a struct, basically group of data, one of those is another group of data. So group of data accessing that inner group, and then from the inner group, I'm picking up day, then picking month, then picking year. Similar fashion, to get the resident info, I'm gonna say almanager.residence.street. It's a string, so I'm gonna say 1, 2, 3, Ford Road. Then I'm gonna say, hey manager, residence, city. I'm gonna say Plymouth. Then I'm gonna say again, almanager.residence.state equals I. almanager.residence.zip. Was it a string? Yes, 4812 48075. Yep, string. Save. Now that I did this, I can just go ahead and display stuff. So see out. Here is the manager's information. I can start by the name. Manager.name. I can follow by manager.number. I can follow up by manager.date, birth date dot day. Copy, paste, and L. So birth date, then month, then year, and then I can show the residence for this. So see out manager dot street residence dot street. So street, then city, then state, then one more state, then zip. We don't need this section. We don't need this section. Yeah. So let's go now. F10. Manager, name, number. Right now, I can expand. I can see name, number, and then I can also expand on birth date. I can also expand on residence. If I expand, it's still garbage. If I expand residence, it's still empty. So day 1, 2, 3. Now, if I open day, it's 10/10/1990. Same for the residence. If I open now, residence 1234 Road, Plymouth, MI 4805. Now I'm about to display. So run. Here is the manager information, name, number, date, and then residence. Nested structures. Then the book needs you to know how to send the structs as function arguments. And it's very simple, just like any other data type. The same way you pass data to a function using primitive data type. Primitive means the opposite of ADT, abstract data type. Abstract data types are data types that are created by a programmer, by the programmer. Primitive data types are data types that come with the language. For example, integer, I didn't create or define an integer or a string. These are primitive data types that come with the language. So just how you pass primitive data types to functions and back from functions, the same way you're gonna pass struct variables and return them from functions. So let's see an example. Let's say I'm gonna take out this code, then I'm gonna call display method and give it the manager. So display, in this case, display is a void function and it takes a employee info as a data type. This is the prototype. So now I go and define it. It's a void called display. It takes employee info. I'm gonna call it input. Then I'm gonna dump the display code in it. And I can pass it as constant because I don't really need it to be changed. As a matter of fact that it's being passed as copy, I don't care. But to make it light on the system, I always pass const references to display functions. So the display function will receive a lightweight input. Lightweight because it's an address of a data type. So employee info, let's say employee info has 10 integers in it. Every integer is 4 bytes. So the size of employee info would be 40 bytes because it has 10 integers. If I want to pass 40 bytes around functions from here to there, then from there back to here, so it keeps going back and forth. Now, 40 bytes in today's systems is lightweight, but imagine it's much bigger. Let's say it's a file that is 1 gigabyte. In order to make it, in order to improve the performance, you shouldn't pass a copy of the 1 gigabyte every time you call a function. Every time you imagine, every time you're calling a function, you're duplicating the size. You're copying what additional 1 gigabyte. Right now, if I want to pick a file that is 1 gigabyte and I want to copy and paste it, it's going to take time for it to copy. So the rule of thumb is anytime a function or anytime we don't care about the changes inside a method, meaning main, when it passes manager to display, it's not expecting anything in return, and it's not expecting anything to change. It's not expecting anything in, it's not waiting on any result from display. So because this is the logic, or this is the responsibility, or this is the job for this function, you better always pass it as const, because, you know, just to be safe, saving yourself or protecting yourself from yourself. By putting const, you are guaranteeing that this is not going to change. This method cannot change this object. It can only use it, read it, but not change it. So this is a little important. The more important thing is pass it by reference. Don't pass it as a copy. So if you pass it by reference, then anything that happens in this method will be reflected in the main. But the fact that we passed a const reference, now the power, now we can see the power of it. By combining both const and reference, you're making it very lightweight, and you're guaranteeing that this method is not gonna do something that is not expected from it or different from its behavior. So const reference display. So let's go here and tell it const reference. For example, if you want to show the difference, I'm gonna have another one that has a void. It's gonna it's gonna be called populate. This, in the other hand, I need it to populate, and I need main to know about the changes in populate. So populate is gonna receive the struct by reference, then populate is gonna change that input. Since it's reference, then main is gonna know about that change. Once the changes are reflected in main, then I pass it back to display. So I'm gonna move all this. I'm gonna say populate L manager. Then I'm gonna go here. I'm gonna say void populate. It takes employee info by reference. So now input, 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 input. So since this populate is receiving the struct by reference, anything that happens here will be reflected in main. So populate will change this, and main is gonna know about the changes. Then it's gonna pass the same variable to display. So the fact that this is not const, it allows it to change. If I put const, then it's gonna say, hey, you can't do that. You're doing something that is not permitted. So remove const. Populate is allowed to change the instance by the reference. However, display is not allowed to change the reference, and my program is very light because it deals with references instead of actual copies. Now, if I run, I'm gonna see the info on the screen. Here's the manager info: Khalil 1, 1010, 1990, 1234 Ford Road. So feel free to do the same thing and step through the code if you don't understand, and reach out for any questions. Now, let's go with the book. Then the book shows how to return a struct from a function. So let's say I have the same example. However, populate takes an employee info and returns it. So takes it by copy and return another copy. Or I can just not send anything and tell populate to return something. So now it would be like this. Populate, at the beginning of my program, I'm declaring a local instance called manager, and then I'm telling populate to give me the instance, and then it gets assigned here. When you use equal on struct, it does what's called member-wise assignment, means automatically, or not automatically, intelligently, it goes to each member from the right side and assigns the value to its relative member on the left side. So populate will return an instance. That instance has string, name, and number, date, residence. It's gonna grab name from the right side and assigns it to the name on the left side. Then it's gonna grab number from the right side, assigns it to number on the left side, and so on, so forth. So this does member-wise assignment. Populate is gonna return me an instance, and then I'm gonna pass this instance to display it. So populate doesn't take anything. Locally, it returns employee info. Locally, it creates called result or return, right? Locally, this is not a manager, right? In my scope here, I'm a function, I'm a worker function. I don't care about the outside world. I care about my scope. I don't have to think about the outside world. My job is to return an instance that is populated. So here is the return type. This is my return. This is what I should return. It's called I'll return. So I'll return. So inside this scope, I don't care if this is a manager or a CEO or a regular employee. I care that this is what I need to return. The naming is very important. Almost half the documentation of your code is the variable name. If you can pick the right variable name, you don't have to document your code. You don't have to comment, oh, this variable is to do this and that. Oh, this function is to do this and that. If you pick the right name, then the information is going to be in the variable name. For example, employee info, I'll return this what would be returned. Okay, this what would be returned. Okay, I know it from the variable name. I'll return. So picking the right variable name gives you a lot of advantages, especially on the long run when you write a code and then you come back to it 2 years later. 2 years later, you're gonna forget everything that you did in the past 2 years because you're gonna write a lot of code. So you're gonna come back to your code and then you're gonna look at it and it's gonna look new to you. Like you're not gonna remember right away that you wrote this code. So variable naming is very important. And as a matter of fact, I can return it as a reference as well to make it lightweight. So return it as a reference, then populates it, displays it. Let's run. Populate must return a value. Oopsie, return return. Bad allocation. Where did this come from? Line 40. Acceleration reading error from here. So return it as a reference. Yeah, it should work. Fine, don't return it as reference for now. I know with all these updates on Visual Studio, it's breaking things. So here it is. I returned it from the function and then passed it to a new function and displayed it. Then the next topic is 11.9, which is pointers to structs. So I can have also pointers to structs, just like any other primitive type. For example, actually, let's keep this. So populate, this will populate. Then I'm gonna tell it, I need, just like you do with pointers, if you need an integer pointer, you say int asterisk lptr, right? So I need this data type, a pointer to this data type, and then I'm gonna call it pointer. Null ptr. Then I'm gonna say, hey pointer, I need you to point at manager. Now that this pointer is pointing to manager, I'm gonna tell display that you receive a pointer to an employee info pointer. And then I'm gonna pass pointer. Now that I receive pointer, then the fact that it's pointer, I can't use the dot operator anymore. Because it's a pointer, I need to use the arrow. When I open the arrow, I'm gonna see the name. So anywhere we are using, I can do this. I can select and then Control F. This will search, find. If I expand, then this is a replace, meaning I can say wherever there is input dot, I need to change it with a input arrow. And here, this is to match the case, means be specific. Anywhere you see, for example, if I say be specific and I put it capital letter, then it's not gonna find it. A input dot. It's gonna say I can't find it. You're trying to match the case. There's no results. So I tell it, no, I need it to be small letter. This is to match the whole word, not part of it. Use regular expressions as is. Selection. Selection, you can change it, for example, to current document, to all documents, to this project, to entire solution. In this case, I need only the selected portion. Within my selection, Anywhere there is input dot, I need to replace it with input arrow. This will do it one at a time. This will do it for all. I'm going to do it for all. Now they have been replaced. I can save. So notice I'm receiving a pointer and I'm displaying it by doing the arrow. Arrow this, because it's a pointer. Run. Here it is. And for my pointer here, for example, let's say I displayed, I can say, hey, I need new employee info, L second, for example. I'm going to call it second. Then I can say PTR and reassign it. Reassign it new address, LPTR, and then display it. See what it has. It has garbage. So this is the first one, and this is the second one. Garbage and empty. Empty, 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 and the garbage. So I have one pointer, and then I'm reassigning it addresses and passing it around. Then you can do dynamically allocated struct. So for example, this is the pointer. Let's say populate returns populate returns a pointer. So go here, return a pointer, go here, create a pointer. Actually create it as is, but at the end return its address. This is wrong. Why this is wrong? I'm going to give you like 10 seconds to think about it. I'm creating a local variable, then I'm returning its address. And this is not the right way to return pointers from functions. There are two cases where I can return a pointer from function. One was if the pointer has been passed from the outside, and another was if the pointer was dynamically allocated. Why? Because in this case, this is local variable, meaning by the end of this scope, this local variable will be destroyed. So whoever receives the return from this function would expect that this pointer is still valid and still pointing to valid data. However, it's not the case. Whoever is going to receive this pointer will be pointing to a destroyed item. So one of the right way to do this is if the pointer is dynamically allocated and we didn't release it, we didn't call delete on it. So what I can do now, I can say I need employee info pointer L PTR, and I'm gonna call it return PTR equals the new employee info. Now that I did this, I need to replace all my returns L return with L return PTR. Now that I replaced these, oh, I also need to replace the dot with arrow in all my selection. Yep, replace, save. Now that this is dynamically allocated memory and it's not released, we didn't call delete, I can freely return it. Now populate returns a pointer. So employee info is a pointer, manager. This pointer is dynamically allocated. Then I'm gonna pass const point manager ptr. So display takes this to display. Once I'm done, then I need to release the memory. How many times did I call the keyword new? Only once. So I only have to call the keyword delete only once, and I call it at manager pointer. So let's run. Step into, I'm declaring, creating dynamically allocated memory. If I expand, it has garbage. So now I'm populating it. Now it doesn't have garbage anymore. So I'm returning it. Then I go in, I'm receiving a pointer to struct. I'm displaying its info. Then I'm deleting it. Now I should set it to null. Here it is, still something is still left over, so I can say L manager ptr equals null ptr compile. Now it's null, so now everything is literally released and cleaned. System pause, here are the info. Done. Sweet. So this is dynamically allocating a struct. I need you to go over table 11-3 just for a quick review to remind yourself of the different expressions. There is S or instance arrow member. You have asterisk struct dot p and all these different notations. I need you to go over this and fully understand them. And if, in case you don't understand something, try it, practice it on Visual Studio, reach out, ask questions, but you need this. You're gonna see them in the test, like true, false, multiple choice. What will this display? What's wrong with that code? Stuff like that. So you're gonna see these notations a lot and expressions, and make sure you have solid understanding. Then the last topic is 11.11, which is enumerated data type. They included this section inside this topic because enumeration or enums, we call them enums, are abstract data types as well. Enums are a data type that is created by the programmer. So let me take all these out. Enums. So enumerated data type is a data type that is defined by the programmer, and it consists of values known as enumerators. So enums or enumerators, they represent integer constants. For example, if you remember in your project, we specified that suit A is 1, something like that. Suit A is 1, suit not suit A. Let's say, for example, spades is represented by first suit. Hearts is represented by second suit. Diamonds represented by third suit, and so on and so forth. Ace was represented by 1, Jack by 11, etc. So the fact that we started the design this way, you're going to end up seeing in code if something like this. If suit equals 1, do something. Somewhere else, if suit equals 3, do something. And sometimes you have logical with it. So if suit I don't know, player 1 equals 3, and suit 2 is not equal 3. So all over your code, you're gonna see all these literals: 1, 3, 3, 3, all over your code. If you write a big and complicated code using this approach, and then let's say you leave the company or whatever happens in the field, we call it hit by a bus. Hit by bus meaning hit by a bus. It was derived from ancient Greek. Sorry for yes, in software. Phrase used when evaluating how much risk exists in a software project, more specifically if the project succeeds, or success is too dependent upon any one team member. So what if you write this code and then you get, God forbidden, what if I write this code and I get hit by a bus? Then another programmer will come and look at the code and try to like figure out what the hell did he mean by 1? What the hell did he mean by 3? Okay, then I need to go back, read all the documentation. You know how time consuming that is? Let's say the code is 5 years ago. Now I have to go read 5 years old code in a 5 years old technology and go find the engineer or the member that collaborated, and maybe they left too. At 5 years is a long period. People come and go in 5 years. So it's going to be very hard to understand the code just for the fact that we used this design. So enumeration or enumerators solve this problem. Enumerators represent integers and they are defined by the programmer. So you as a programmer, you can come and say, I want a data type that has 5 items in it. The first item represents 1. The second item represents 2. The third item represents 3, for example. Enum suits, right? I'm gonna say spades, hearts, diamonds. What more? What else? I forgot. Been a while I didn't play cards. What are the 4? Spades, hearts, diamond, clubs. Yep. Clubs. So by default, this starts at 0. Then incremental. So 0, 1, 2, 3 means if I have an int suit and I say it's equal to 3, let's remove this. Let's say I have this variable somewhere. Then I can check if suit equals, instead of specifying 1, I can specify hearts. So suit is 3, hearts is 1, then this will not execute. If suit equals diamonds or clubs in this case, because it's 3, see out, it is so run. Why it is a clubs? Because it is equal to 3 and the clubs is 0, 1, 2, 3. So this would be much better. When I go and read in the code, if suit equals hearts, I can understand right away what it means. Means the player has a card that is from the hearts suit, unlike when it was equals 1. What did we mean by 1? Right? We don't know. Nobody knows but the programmer. Even the programmer who wrote it maybe forgot by now what did he pick for suits. So this is what enums try to solve. Let's try another example. Let's say enum is day. Monday, Tuesday, Thursday, Friday, Saturday, Sunday. This is a good example. Why? Because in your code you might have a day equals 1, meaning the first day of the week. Different cultures have different first day of the week. If you write this code using this approach, meaning you meet with your team and then you decide, okay, day 1 is Monday, the first day of the week is Monday, and then you go write a code that represents 1 as the agreement. 1 is Monday, 2 is Tuesday, etc. If you go global, day 1 somewhere else is not Monday. For example, some have Saturday as day 1. Some have Sunday as day 1. And it is true. It's not a fictional idea. It's true. Somewhere else, first day is Saturday. The weekend is Thursday, Friday. In some other groups or places, Friday, Saturday are the weekend. Here in the United States, it's Saturday, Sunday. Saturday, Sunday are the weekends, and Monday is the first day. So in case we have Thursday, Friday, then day 1 is not Monday. Day 1 is Saturday. So if you write a code that says, hey, if day equals 1, and you're expecting it to be Monday, but the code breaks in a different country, and right now we are global, right? Like if you build a application, mobile application or software, it's easy to have a user living in the other side of the earth. They can just download it from the Play Store. It's not local anymore. It's not like you go to the shop and meet your users. No, you in case you build an application, your users are around the globe. So what you want to do in order to make the code, it's not going to completely fix the problem, but it at least will make the code more readable, more understandable. So instead of using 1, 2, 3 as literals, you better use enums. So start the day by Monday, and then if day equals Monday, so when you come back to this code, you don't have to figure out things. You just look at it right away and see, oh, okay. If day is Monday, do this in this country, do that in that country. If the day is Friday, then do this, do that. So enums, this is basically enums. It starts by default from 0. However, I can control that. I can say I need Monday to be, for example, 10. By saying 10, then it's also incremental. This is no longer 1, now it's 11. So 10, 11, 12, 13, etc. I can do partial. So I can say I want this to stay as is. Then I want this to be 10, and I want this to be 20. So it's incremental. 0, 1, then this is 10, this is 11, 12, this is 20, means this is 21. So if we want to write a quick code, we can demonstrate how we can compare, like a greater than, less than, how to assign. We can do something like this. So let's do const int num days. Number of days is, for example, 5. I have 5 days in a week, and then I have sales for num days, array of sales. Then I have double total. If I want to collect, let's say it starts from 0 because I need to keep running total. Then I have index whatever day I'm on for the loop. So now I'm gonna say for int I, or index, basically I have it already, from Monday to int Friday I plus plus index less than or equal, because I want to include Friday index. So in this case, I'm going to say cout, enter the sales for day index. It's going to start from now, so it's going to be understandable. Cn sales at index. Sen Cn. Now that I did that, I can redo to display. Actually, to calculate the total. So from here to there, total would be plus equal, starts from 0, plus equal is whatever sales at this index. Then I can say cout total. Yep. So notice I'm not using any literals except for num days. It's in one place for all the arrays, so I can change it in any way I want. In case I want more business days, I can just go to one line and change it. However, all over my code, I'm using meaningful words instead of just literal numbers. From Monday to Friday, from Monday to Friday. So enter sales, I'm going to say 10, 20, 30, 40, 50. It's 150. Here it's clear and the code is clearer. So that's enums. There are good examples in the book if you want to practice it. Yep, and this is it for the chapter. Let me know if you need help in anything in this chapter. I'm going to assign you the homework and the project today, and I'm going to do the new lecture about intro to classes. Have a good day.